Astrophotometry log. It is July 27th, 2012. It's approximately 1954 UTC at the time of this recording. This is the latest AIA 193 angstrom image from SDO as treated with the nice little grid and the contrast enhancements by solarmonitor.org. And this coronal hole, 11526, is the same coronal hole that has been present on the sun since the Japanese earthquake. And I have done several watches that have been based on the recurrence of this hole. And so far, there's not a clear correlation between this hole's recurrence and additional very large seismic events. There's not a clear correlation. And it is surrounded with active regions that have made this a little more of a challenge. But we're getting ready to see the geo effect of this hole as it is turned back towards us now. And I wanted to go ahead and do an informal earthquake watch for a particular area that is based on a new mapping technique that I have been looking at. I haven't had the time to go back. It would probably take 2 weeks, maybe a month, to go back through the record of the earthquake to coronal hole correlations and try to visualize, try to see if this new model is actually correct. But I'm going to go ahead and do this informal watch based on it. I'm going to kind of hold back on doing earthquake watches for recurring holes, as this one has kind of put a bit of a hitch in my forecasting. This forecast didn't turn out very well. This was the one that I reissued from June 30th, and then it was reissued from the past time. So every 26 days, this hole comes back around into a geo-effective position, which we're getting ready to see, like I said, the incoming solar wind from this. And so I thought I would go ahead and reveal the latest thinking on this mapping technique. What I visualized from the nature of my study of these coronal holes and working with the model of astrophotometry is that the coronal hole itself is thought to be a disturbance in the hypertime translation as it relates to the Earth's orbital consistency. And so we have this area on the Earth that is now inconsistent with its previous yearly position. It takes a year, theoretically, for the Earth to go around the sun. And so there's this orbital inconsistency because of the movement of the Earth with respect to itself. In other words, we have this place in Japan where the Earth has shifted. And so these changing coronal holes relate to that consistency, the consistency of the Earth with respect to the other parts of the Earth. And we see these dark patches as the carrier wave, as the carrier form is out of phase with itself from the previous years. And so that's why I call this a hypertime shadow of orbital inconsistency. Now, the more recent discovery is that what these other areas might represent are changes in elevation. And so I've been trying to look for a way to map this to the shape on the Earth. When this hole first formed, right before the Japanese quake, there was a shape on the sun that looked like the continent of India. And so I've been looking at water boundaries, I've been looking at plate boundaries, I've been looking at the shapes of continents. And And now I think I might have finally figured out how to do the mapping, and I wanted to go ahead and share that with the other researchers. I'm not sure this is correct yet. I have looked at a few past events. It definitely fits for the Japan event and a couple of the other events that I've looked at. But what I'm looking at now is the elevation of the Earth. And so if we look at the Earth, we have different elevations that determine the coastlines at times. But there's places where the coastlines taper off very, very slowly. And you've got these places where there is sort of like this flat area right off the coast, and it's just, if the sea was just a little lower, we'd have all this extra continent here. And then you've got these very, very deep areas, these canyons in the ocean, and mountains in the ocean that are beneath the surface that poke up, the top of them poke up as these little islands. And what I'm looking at now is the slope of the Earth with respect to these coronal disturbances. And so I'm looking at it like these bright spots actually have something to do with protrusions, composite protrusions. In other words, there's a composite nature to the view that we have of the sun, of these protrusions out of the water, out of the into the air, and so there is a slope overlay for Google Earth, and this isn't something that I can afford. This isn't a free product, but you can see this is colored based on the slope, not just the elevation, but the slope of the elevation, and this is the best way that I can think of right now to map this that I've been able to find. If you look at the Earth itself with respect to these regions, for example, for this particular coronal hole, we have this area over here that's of high elevation. This is Hawaii, and then you've got these little mountains under the sea. And then you've got this deep cleft right here. Then you've got this ridge right here that runs all the way down around here. And you see this ridge? It's not necessarily a fault line. And before I was looking at fault lines, but it's the elevation of the matter, of the mass of the Earth. And you've got this little shape right here that is fairly consistent with this shape. And so you have this potential relationship with these landmarks, these mountainous features, that it might be possible to use a computer algorithm to match up exactly. Okay, and so if this is indeed this area, if this does map to this area, the question is then, what is the epicenter? Where is the epicenter? If this represents this little valley and there is an inconsistency in the hypertime translation, which is about to hit the Earth in the form of this disturbance in the carrier that indicates a potential movement of the ground, where exactly would that be based on this? And that's a fairly tricky question. And I think at this point, I would have to say it's the places where the sharpest edges are on this. And so it would be like this area right here, possibly, and possibly this area over here. It's also possible that it's just the center of the disturbance. So if this is the disturbance, if this is the inconsistency in the hypertime translation, it could be that this is the center of whatever pressure would be affecting this area. And so we're seeing a sort of ripple through time space from the Japanese event that is coming back in a sense, in a different place. And based on the size of this hole, if this was an independent hole, if this wasn't just a recurring hole, I would say that this would be like a 7, possibly 7.2 quake. It could be larger, it could be smaller, but based on the ones I've seen before, the one for the Japan quake, the coronal hole for the Japan quake was by far the largest coronal hole we've seen in a very long time. But this coronal hole isn't nearly as large. And so I would say possibly in the 7s. Again, it's a probability as far as I know right now with the method. There's also another coronal hole over here right now that if this mapping is correct would represent New Guinea. And so there's a potential for some activity also around New Guinea after this other activity that might be on the way. And so that's the watch. I'm looking for activity in this area right here, and potentially some of these little islands in here. We have seen some activity in this area, and so it wouldn't be too surprising to see additional activity in this area. And I want to encourage anyone that's doing earthquake forecasting using my methods to contact me about this new potential way to do this. And if you're interested in working on a computer algorithm, if you're a programmer and you want my input on the math for this, use the elevation data set that Google has for Google Earth. And what we need to do is write a algorithm that looks at the slope with respect to different increments, different intervals. So when you take the integral of this area to get the slope, there's always a particular distance over which you're doing it. And so we're going to want a multivariate slope calculation based on the elevation data set that Google Earth, that Google already provides us, I think, part of the Google Earth development kit, or at least there's definitely the Google Earth plugins for that data. And it may be some cross that works out better, some multiple of the elevation versus the slope, or like I said before, the multivariate integral with respect to, in other words, a particular distance. So if you're someone who wants to work on that, or if you're wanting to get additional information or have questions about it, just post it. So this is the same earthquake watch that's coming back around for this new time. And we should be seeing very soon the solar wind. This might actually be the ramp up for it right now as I'm making this. I usually like to try to make these watches more or less right before, within 24 hours of the time when these events arrive. And, you know, I said before, this is not really suitable for emergency response at this point. I really wish it was suitable, but it hasn't been perfected to that point where, you know, it would make sense to warn anyone necessarily in these regions. We just don't know well enough, in my opinion, to do that. And so here's the information. Thanks for watching, and send this out to anyone you think might find it useful. Thank you.